Welcome to VisSim. Visual Simulation Modeling Language was written for electronics engineers back in the 80s, but you can use it for any mathematical model, and you can share those models for free. If you received a model and need help viewing it, this demo should help you understand how to read the model you have. I'm using the VisSim trial version, which lets you save models, but the viewer only lets you view them. You need to know some basic electronics jargon to use VisSim. DSP terms like signals and wires become obvious once you start working with the interface. This demo will graph a sine function. In DSP terms, the sine function is a signal producer, wired to a signal consumer, the plot block, which can be simulated in real time. VisSim has a drag and drop interface. Left-click to pick up a block, drag the shadow that appears, and left-click again to drop the block. Each block you add bumps up a counter in the status line at the bottom of your screen. Clicking the green arrow causes your simulation to appear. That's my pretty sine wave. To show VisSim's filter capabilities, I have to mess this up by adding noise. You can join signal producer blocks with a sum junction, which again is a new type of block. By doing this and running the simulation again, you can see why engineers generally like to avoid noise. Now and then you see that I've got the status line at the bottom showing the number of blocks that I'm adding to my screen. This is important when it comes to collaboration. The VisSim viewer is free, but there's a limit to the number of blocks that the viewer can handle, which I think is 100. Okay. I'm adding my noise here. Wire it up. Click Go. Choose the green arrow again. And there I have my wonderful noise, which is the reason why engineers like to avoid noise. Okay, this is good. Now we can go filter it out. I'm going to use a transfer function for this. To filter the noise, I use this multi-use block that executes a single input, single output linear system. To configure parameters for any block, just right-click it. When I right-click the transfer function, I enable the transfer function wizard. In this wizard, I have several options. As a heads up to MATLAB and Simulink users, you can enter your .m and .mat files here. The online help tells you all about those options, but I'm going to go get a filter. I could choose between infinite impulse response filters, IIR, or finite impulse response filters, FIR. For this demo, I'm using low-pass Butterworth. I'm changing it to second order and recalculating. Click Done, which returns me to the transfer function wizard, and click on the option Display Filtered Method, because the block label defaults to the polynomial coefficients. And click OK. Now there's my Butterworth filter, and I wire it up to a contrasting color using the same input. Running my simulation now shows how closely the result matches the original signal. Okay, this is a trivial model. Let's imagine it was huge and took up my whole screen. To use VisSim to model in model-based design, you create compound blocks to organize your models. Just select the blocks with your mouse to send to a lower layer. I'll select the sum junction and the filter. With my mouse hovering over one of those selected blocks, I right-click it to see the option to create a compound block. You can nest compound blocks to as many layers as you want, and you can have them run at different speeds than the upper layer. The thing you need to remember about compound blocks is that to change parameters of the compound block, you need to use control right-click, because a simple right-click takes you just down to the lower layer. Coming back from the lower layer, you right-click on white space, and when it highlights in red, you right-click again on white space to make it blue. Right there, I'm going control right-click to get the parameter window. I'm not doing anything complicated here, but this is just to show you where you need to set up your parameters. Okay, I'm going to go back into my compound block and show you that the compound block still behaves just like any other block. I'm going to go back in, I'm going to change my filter to a Chebyshev filter. I have set the ripple to 0.5. And there you see the label is automatically updated. Right-click on white space to go back to my simulation. And now when I rerun, you'll see that the little blue line has changed. That's the effect of my Chebyshev filter. Okay, thank you very much for paying attention to this small demonstration of VisSim.